Hello, this is a small demo of our phase 2 project of DSS. And so the basic extra requirements for phase 2 was that we need to introduce error injection probabilities in the server side, and also we need to have the retry mechanism when there is an error in the request in the server side and not in the client side, what we did in the phase 1. So the two things, the error and the retry mechanism, as said, is in the server side, and I'll show you. So as you can see, this function is responsible for injecting error into the server. So when we mention the random number as 15, it means that we have 15% of the total request to be error prone. So we can manipulate this 15 by 5, 10, and 15 as mentioned in our project outline. So this is how we get the error injection probability in our server. And also for retry attempts, we have a maximum retries, that is 5. So we'll retry for 5 times if there is an error while calling that request. So all these things are dealt in the server side. Now moving on to the client aspect of our code. So the client aspect of the code remains mostly same, but we have removed the retry attempts from the client, because now the server is responsible for retry and not the client itself. So now we move back to our cloud instance. So this is a cloud instance, and we have 4 separate jar files over here. 0% jar. So 0% jar represents what we did in the phase 1 of our project. It says that all the requests are error free. So this jar represents the phase 1 project basically, and these 3 jars are the jar files that we built using 5% error probability, 10%, and 15%. So we got these jar files while building our server project using the Eclipse. So we built it 4 times with different error probabilities, and we got these jar files. Now what we need to do is run the command for to execute the jar file. I'll run it for 15% dot jar. So now you can see that our server is up and running. So we move back to our client part of the code. So we have specified our public IP in our client section, and now all we need to do is run the client. So the client has about 10,000 requests, so it takes around 2 to 3 minutes. So in the meanwhile, I'll describe what results we got from different error probabilities and what conclusion we got from them. So we tried running for no errors, 5% error, 10% error, and 5 and 15% error. And what we noticed is that when we increase the error probability, the response time became lower, and hence the throughput increased. But this is not the case when we have errors. Usually when we have errors, we get higher response times. But in our case, we get lower response time because when we send a request, that request is getting in that case, it is interacting with MongoDB, and the request is getting saved to the MongoDB repository. So when we have an error in the request, we are not processing that request to the MongoDB, and neither are we saving the data into the MongoDB. So in that case, when we have error, we are saving that time, that the time that is getting consumed by MongoDB. Hence, when we have error, we get technically lower response time, and since we have lower response time, we get more throughput. So the conclusion that we get from our phase 2 project is that as we increase the error percentage, error injection probabilities, we get lower overall response time, and hence higher throughputs. So that's it from the conclusion part, and now we wait for our results to be displayed. Okay, so now I think the client has completely executed. So we can see that the successful request is around 8500, which means that 1500 requests didn't pass. So it implies that 15% of the total request had errors. And now we get the throughput and the total response time. So this is the results what we get when we have 15% error injection probability. And now we can run the all the different error probabilities and we can compare those results as well. And we have mentioned all these things in our report. So that's it from our phase 2 demo. Thank you so much.